So again, let's kind of review where we are. The signal goes in, that's me speaking into the microphone. It gets transduced. The microphone, using a vibrating diaphragm, creates electrical pulses, which have encoded the information into an electrical signal. That signal gets modulated in different ways. We've discussed how it can get modulated via AM modulation. We can change the amplitude of the radio wave. Frequency modulation, we can change the frequency of the radio wave. We could make it digital. We could translate the information into binary code, zeros and ones. Here's another way of viewing this. This is a binary code that would translate into this. The smooth wave is an analog wave. The stair step is a binary wave, a digital waveform. Again, this is complicated, but what I need you to know is that there are major advantages to converting signals digitally. Digital signals can actually carry more information. They carry more information per second. So, of course, it's going to be advantageous for us to make digital signals because we want to send as much information as possible. Another major advantage is that digital signals can actually maintain their quality over large distances. If we encode information digitally into a wave of light, then the digital information, the light wave, can actually maintain its integrity over large distances. So, I've spoken into my microphone. My microphone has created electrical pulses. The electrical pulses have been processed, modulated to make analog or digital signals. And then finally that signal is going to get turned into an electromagnetic wave and transmitted, as you can see here. So the antenna of the transmitter, once again, causes an electron to wiggle around. The electron is going to wiggle around with the information, with the same frequency as the modulated process code. The moral of the story is that information is getting encoded and passed on in various forms by humans manipulating and creating electromagnetic waves. Does this make sense? So the signal has gone into the microphone. The microphone has transduced it, created electrical pulses. That information has gotten modulated, processed, and now I'm transmitting the signal by wiggling around an electron using my knowledge of electricity and magnetism, causing that electron to wiggle around, exciting the electromagnetic field, creating an electromagnetic wave, either radio waves or, in the case of Wi-Fi, sometimes microwaves, and that's going to be transmitted out and then it's going to be received. To be received, it has got to be able to manipulate and it's got to affect and excite an electron in an antenna. Like I said earlier, your laptops that receive Wi-Fi, your phones that receive data in Wi-Fi, which are just radio and microwaves floating through the air. Your phones and your laptops have tiny, tiny little coiled up antenna in them. Metals which contain free-flowing electrons, which can be wiggled around very easily by an incoming electromagnetic wave. So now the information is held in the vibrations of the electron, in the oscillations of the electron. If the electron in the receiver is caused to oscillate with a high frequency, maybe that will be translated into a high frequency sound that your speaker will put out. So the so the light wave has been created, it's been transmitted by the transmitter, it's been received by the receiver. Yay. What was next? Reception. Okay, now we have to interpret the code, so to speak. We have to read the code. We've got to transduce the code back out. Let's talk about how a speaker does that. A speaker is incredibly simple, actually. It is made of wire, magnet, and a vibrating cone. That's it. So when the information is received, when the electromagnetic wave is received by the receiver, that's going to cause an electron to wiggle around, which can cause electrical signals, electricity, to pulse. Electricity pulses through wires with a specific frequency and amplitude and all these things. And those wires, as part of an electromagnet, cause a magnet to vibrate. So now the information is held in the vibrations of the magnet, which causes the cone to vibrate, which, guess what, causes the air particles to vibrate, which create a sound wave. And so finally, the information has been transduced, maybe you could say untransduced, gone from electricity to sound. This is the exact opposite of what the microphone did to begin with, right? Remember, the microphone to begin with took sound waves and through vibrations of a movable diaphragm used an electromagnet to create electrical signals. Well, that's the exact opposite of what's happening here. We're using electrical signals to move around an electromagnet and create vibrating air particles of sound waves. This has been a lot, and maybe a lot to swallow, so let's review it one last time, shall we? The signal has to come in. That's me speaking. I'm generating sound waves. Those sound waves can be thought of as forms of information, carrying information, frequency, amplitude, all this stuff. That information gets conserved and converted into electricity. It's just energy conversion, right? We're converting one form of energy, the energy in the sound wave, to electrical energy. A microphone does this. That information then gets processed and changed, modulated as an FM or AM signal or a digital signal using binary code. It then gets transmitted through an electromagnetic wave that we create by wiggling around electrons. That electromagnetic wave travels through space, and it gets received by the receiver. And so we have this electron getting manipulated. We have this electron that is receiving the information, receiving the encoded information. All we're doing is getting these electrons to mirror each other, right? By vibrating an electron over here, the wave travels and causes this electron to vibrate in the exact same way. So now the information, which has been encoded in specific frequencies and energies, the information is held in this wiggling electron. It's been received. That wiggling electron is going to create electrical pulses. And so now the information is in the form of electricity, and your speaker is going to transduce. It's going to convert the electrical energy into another form like sound waves. It's the exact opposite of what the microphone did up here. And the speaker does that with an electromagnet. And then the sound is going to come out. The signal is finally going to come out. And all of this, as you know, if you've texted someone or called someone or ever sent a message, can happen in the blink of an eye, which is absolutely insane. To end, I want to talk to you about what I think is a pretty cool way to send signals. And it is an analog way of sending signals, and it's a very old school way of sending signals, but it's a way that's kind of resurged amongst you hipsters in the past few years, and that is through vinyl records. So a record stores information because the record literally has grooves scratched in it. So imagine this black that's moving down here is a record spinning, and the record company has scratched grooves in the record which correspond to the sound waves that were recorded. So imagine a band in the studio recording a song. Those instruments and the vocals and all this stuff have specific sound waves with specific frequency and amplitude and blah, blah, blah. All that gets encoded in a physical form by grooves in a piece of vinyl, just like this. When you put it on your record player, the stylus follows those grooves, and now the information is in the vibrating stylus, which uses electromagnets to convert the information into electrical signals, and then speakers take that information and convert it back to sound. Here's a really close-up picture of a groove that's been scratched into a record. Here's what I'm getting at. The needle is capable of following the grooves, and so now the information is held in the vibrating, oscillating needle, and that causes, with the help of electromagnets, to create an electric current, which is analogous to the sound waves that have been encoded in the grooves. And the speaker is going to pick up this electrical information. It's going to vibrate the speaker with specific frequencies and amplitudes, and you're going to hear the lovely, lovely sounds. Speaking of records, let me end by telling you one of my favorite scientific stories. I don't know the dates. I'm a little bit rusty on that information. But sometimes in the 60s or 70s, NASA was preparing some missions known as the Voyager missions. And these were satellite probes that were going to get launched into space and basically never ever come back to Earth. They were launched to the outer solar system. In fact, one of them we think has maybe even hit the border of our solar system, so it's gone beyond even the orbit of Pluto, way out there, almost to interstellar space, past the influence of our sun. Some of the fastest traveling man-made objects ever, the Voyager missions. And NASA commissioned groups of artists and scientists to create a golden record that could be placed on the Voyager satellites, the Voyager probes, in the event that they are ever picked up by some alien civilization. Now, really, that's not going to happen, I'm sorry to say, as much as I wish it to be true. So it's more of a symbolic gesture. This is what the golden record looks like. On one side, there's etched into it some encoded information about what we know about atoms, what we know about space, what we know about the universe. In the lower left of the record, you can see a map that scientists created that they think that any intelligent species that has language could be able to discern. And on the other side of the record, it's an actual record, just like we just discussed. They got the artists and scientists to try to figure out what songs, what sounds would we want to encode onto this record to represent Earth. They put on the record things like children saying hello in many different languages. One thing they put on the record was the brain waves of a woman. Brain waves are basically the sum of the electrical information, the electrical impulses, the electrical signals in your brain. We can pick those up and we can kind of put them in waveform. And this woman's name was Andrewian, and she was married to one of my favorite scientists ever named Carl Sagan. If you've not heard of Carl Sagan, you need to go look him up immediately. And Andrewian and Carl Sagan actually met in this project and worked on this project, and Anne volunteered to have her brainwaves read and to have that information placed on the record. And this was a time in her life where she had just fallen in love, and whenever her brainwaves were being read by the machinery, she thought about Carl Sagan. She thought about her love for him, and so really one of the object that humans have created that's gone the farthest that any man-made object has ever gone or possibly ever will go, even beyond the scope of our solar system, is carrying on it the love of one human for another. Yeah, maybe you think that's kind of cheesy. I think it's kind of dang cool. The golden record for me serves as a reminder that on our blue planet, our tiny, tiny little insignificant planet in the scheme of things, a little blue speck, a little dust mote floating in the sunlight, that we're all human. We all just want to be loved. We all want to find someone to love. So if you remember one thing from this silly little online course, I hope it is this, that we're all humans on this planet together. This planet is the only one we've got. This species of humanity is the only chance that we have. So we should try to work together. We should try to love each other. We should try to make a lasting impact on the planet for good, for the better. Each of you are capable of doing that. Each of you are capable of loving, being loved. We're all capable of making a positive difference on the planet, in a single person's life, whatever it is. So we're all in this together. This is our planet. We've only got one shot. So let's be friends. Let's make our chances count. Let's try to be good people. Let's try to understand that we're all humans. We all have fears. We all want to be loved. So let's love each other. Let's work together to make the world a better place. And maybe if we can use science to do that, that's great. Thank you guys for putting up with me all semester. If you have any questions, let me know. I appreciate your hard work.